Hello and welcome to another video. In this section we are going to be looking at factoring quadratic equations. We've broken section 4.2 up into two different parts. In this part we're just factoring, reviewing how to factor, and then in the second part we're actually going to solve quadratic equations using factoring. And if you remember from our last video, we looked at solving quadratic equations by graphing. So if you're okay with factoring and you don't need much review, you could skip ahead to the part of the video. There should be a timestamp down in the description, and it should say factoring quadratic expressions. Go and start there. If you need some review with factoring, you can watch these examples, or you can watch a few of them, maybe one of each type. We got common factoring, factoring some trinomials, and then a difference of squares. After you maybe see one of each, then you could skip ahead as well too. Okay, so for the first one, common factoring, this is where there's only one kind of thing that you can pull out from each of the terms. Just each of them have something that you could pull out. So I see that they all seem to be multiples of 5, so I could pull a 5 out from all of them, the number 5, but I see they all have x's as well. Okay, they all at least have one x, so I can pull out one x, and they all have at least one y, so I can pull out one y. And then in brackets we write whatever is left over. So from the first one I pulled out the 5, it's gone. I pulled out one of the x's, so there's going to be 2 left. And I pulled out the y, so there's no more y's left. With the next one, imagine breaking this down into 5 times 3. We pulled out the 5, so we just have the minus and then 3. And the x, there was 2 of them, but we pulled out 1, so now we just have 1 left. And then the y, we pulled out a y, so there's no more y's. Then the last one, 10, that's just 5 times 2. We pull out the 5, so we just have a 2 left. We also pulled out this x, and for the y, we pulled one of them out, so there's 1 left over. So that would be your answer for the first one. For these next ones here now, these are trinomials. They're kind of a different type because I'm going to be able to do more than just say pull out a common factor like we did with this top one. So whenever you have 3 terms like this, what you want to try to do is you want to use the product and sum method. So the product sum method. So what you do is you take the first number, there's a hidden 1 there, times it by the last number. So 1 times 12, that is going to be 12. So 1 times 12 is our product, so product of 12, and the sum is the middle number there, so negative 7. And then what you want to do is you want to try to come up with 2 numbers that multiply to 12, but they sum to negative 7. So the 2 numbers that are going to do that are a negative 3 and a negative 4. Now if there's just this 1 in front, I call this type kind of the easier type because to factor it, it's much easier. All you do is you put 2 brackets, you put your variable in there, so x, and then you put in the 2 numbers that you just found, minus 4 and the minus 3. Okay, and that's your final answer. If they don't have that 1 in front, we're going to see some of those down here. Those are a little bit harder, and we'll see how to do those when we get to them. For this next one, again, we're going to do the product and sum because we got 3 terms. Product is hidden 1 times by negative 6, so that is negative 6. The sum is the middle number there, which is a hidden negative 1. So we got to try to find 2 numbers. They'll multiply to negative 6, and they'll sum to negative 1. And the 2 numbers that are going to do that are a negative 3 and a positive 2. So to factor this, it's just x minus 3 and x plus 2. If you wanted to check any of your answers, you could FOIL this back out and see if you get this. Another way, if you wanted to check this, is using your calculator. So all you do is you graph what you originally had and graph what you got. And if you only get one graph, that tells you that they are equal, they are the same graph. You only get one picture. So I'll just do that really quick. So there's our first one in, and then I'm just going to put this in. So now that we have both in, I'm going to click graph, So it's graphing the one, and then this is still blinking, so it's graphing the other, and it graphed it right over top of the other one. So I only get one graph, so that tells me these two things are equal. They're overlapping. Okay, so that's how you can check. On to our next one here. This one, we don't have a leading one, so it's a little bit different. What I'm going to try to do first, though, is see if they all have a common factor, and they all are multiples of 2. So I'm going to pull a 2 out first. That's going to leave me with this. Okay, and then now what I'm going to do, I got 3 terms. Now I'll do my product sum for what I have left here. So product is 1 times negative 10. That's going to be negative 10. Sum is the middle number, positive 3. So I got to find two numbers that will multiply to negative 10, sum up to 3. That is going to be 5 and negative 2. And then it just breaks apart into those. So x plus 5, x minus 2. And the order that you put these in, it actually doesn't matter. I could have them flipped. Same with these ones. Order doesn't matter. For our next one there's not a leading one, so it's going to be kind of the harder type. I want to see if I can pull something out from all 3 though, and in this case I can't. So I got to go to my product and my sum. So my product is 3 times 12, so that's going to give me 36. And then my sum is the middle number, negative 13. Okay, and then two numbers that multiply to 36 and sum to negative 13. So the two numbers that do that are negative 9 and negative 4. So then what we do is you rewrite what you had, but this middle term, it breaks apart into a minus 9 and a minus 4x. So we got minus 9x minus 4x plus 12. Then we look at the first two as a group. I see both of those have a 3 and an x, so I can factor out a 3 and an x, and then I'm left with x minus 3. And then with the next two, I see both of those have a factor of 4, so I'll pull out a 4. And if this is negative, you want to pull out a negative. So we pull out negative 4, and I'm left with x minus 3. And then what should happen is these two things in brackets should be the exact same. So I can factor that out from both of these. So if that gets factored out, I'm just going to write it at the front. That's factored out. And then the leftovers are these right here, 3x and minus 4. So those two get their own bracket. It's 3x minus 4. So that method is called factor by grouping because you kind of make two different groups and then you factor them in those groups. So now that we're done that, on to our last one. So this one, all of them have a factor of 2, so I'm going to pull out a 2 and I'll be left with 2x squared minus x minus 6. Okay, and then I'll do my product and sum because I got 3 terms. So 2 times 6 is going to give me a product of 12, and then the sum is that minus 1 in the middle. So the two numbers that do that are negative 4 and 3. So this one I'm going to factor a little bit differently. So we have the 2 out front. What I'm going to do now is this one's called the fraction method. What we do is we basically pretend like this front term was a 1 and we just write out our two terms. So it was x minus 4 and x plus 3. Then what we do, and this is why it's called the fraction method, is because this actually wasn't a 1, we need to divide by that number. So divide by 2, and then we get our fractions. This one I can simplify, so I'm going to simplify that one. So I'm going to get x minus 2. And then with the other one, I can't simplify this one, so that 2 is going to come up and go in front of the x. So it's going to give me 2x plus 3. And that's our final answer. Okay, so those were for factoring trinomials. Now what we got here at the bottom is factoring a difference of squares. Now this one, it's going to be easy to spot because there's only two terms, and there is a difference in the middle, and both of the numbers on here are perfect squares. So I'm going to write them as perfect squares. 9 I could write as 3 squared, and then x squared is already squared. And then 16 I could write as 4 squared, and then y to the power of 4 I can write as y squared squared. Okay, so now what I'll do is I'll share the exponent for each one of these. So this is going to be 3x all squared. And with the next one, it's going to be 4y squared all squared. And then to factor this, we just take each of these, we put them in two sets of brackets. So 3x is going to go in first in both sets of brackets. And then the 4y squared is going to go second in both of them. And then you put a plus and a minus. So that's our answer. Another way you could do this too is you just take each of the terms, like 9x squared, and take the square root of that. You get 3x. That's going to be the one term in the brackets. And then we would take the other number, 16y to the power of 4, take the square root of that, you'd get 4y squared, and that will be the second term in the bracket. So that's kind of like another way that you can also do it. So now that we're done with the review, we can move on into our examples. So the first one here just says factor the following. So here I see we got a factor of 3 in all of these, so I'm going to try to pull out a factor of 3 first. And I recommend you guys try to do these ones first. This one you can probably do on your own. These next two are going to be a little bit harder, so if you need to watch, you can just watch for those. So here I'm pulling out the 3. I got x squared plus x minus 2 left over. And then I'd go to my product and my sum. Product is 1 times negative 2. Remember, hidden 1 there. So that's negative 2. Sum is the middle term, so that's a positive 1. So we need two terms that'll multiply to negative 2 and sum to 1. So that is a positive 2 and a negative 1. And then this is the easier type because there's just the 1 in front of that x squared, so it's x plus 2 and x minus 1. Now this next one is a little bit harder. Looking at it, there's a half in front. So whenever you have something like that, try to get rid of that half there first. So I'm going to pull out a half first. And that's going to leave me with x squared. And then the next term is going to be minus 2x. And then if I take a half out of negative 4, that'll give me negative 8. Okay, you can check it in your calculator. Take negative for this one, take negative 1, divide by a half, you'll get 2. For this one, take negative 4, divide by a half, you'll get negative 8. Now that we got that, we can do our product and our sum. So product is negative 8, sum is negative 2. And then two numbers that are going to do that are negative 4 and positive 2. And that will give us our final answer. So x minus 4 and x plus 2. Now this next one I can see it's only gotten two terms, so I'm going to probably think it's going to be that difference of squares type. There is a difference in the middle, and the numbers kind of look like squares. So if you took the square root of this, 0.49 j squared, take the square root of that, you're going to get 0.7 j. And for the other one, 36k squared, if you took the square root of that, you would get 6k. So to factor this, we just take each of those terms, set them up in brackets. First one goes first, 0.7j, 0.7j, and then the 6k goes second. And then just put a plus and a minus, and the order of those, they could be flipped. Either way is fine. So lastly here now we're looking at factoring polynomials of quadratic form. So these ones are a little bit trickier. We'll see kind of how to handle these ones. The first one here, we got 12 times n plus 3 squared plus 24 times n plus 3 plus 9. So this one, it would be nice if we didn't have all of this stuff in here and I just had, say, an x, and same with this one, because that would make it a lot simpler. So what we're going to do, whenever you see kind of the same thing being repeated twice, that n plus 3 and n plus 3, what you're going to do is you're going to change it into that variable. So the first thing we're going to do, we're going to say let x equal n plus 3. And then I'm going to change it into x. So this is going to become 12 times x squared plus 24x plus 9. And then I'm going to factor this, and then at the very end I'm going to put back what x actually is. It's n plus 3. So looking at this, I can see all of them have a factor of 3, so I'm going to first pull out a 3. It's going to give me 4x squared plus 8x plus 3. And then I can do my product and my sum for these three terms. So the product is 4 times 3, so that's 12. The sum is 8. So I need two numbers that'll do that for me, and that's going to be 6 and 2. And I'm going to use the fractional method that we did on that first set of examples. So I'm going to have x plus 6 and x plus 2. And then the first term was a 4, so we got to divide them both by a 4. So I'm going to have x plus, and simplify that fraction. That'll give me 3 over 2. Simplify this second fraction. That's going to give me a half. And then I'm going to move the denominator number up in front. I'm just going to bring my work up over to here. So I'm going to have 3 times, and then the 2 comes up, so it's 2x plus 3. Again, this 2 here was just moving up in front of the x. And then we'll do the same thing with that second one. So we get 2x plus 1. Okay, so I've gotten it factored, but we never had this x in here to begin with. So I need to change back what x was. So it is going to change back into an n plus 3. So I got that 3 in front, then I had 2 times, and I'm going to change to n plus 3, plus 3. And then for our second one, same thing. And now that I have that, I just start to simplify everything that I have. So I'm going to have to distribute the 2 into those brackets. So that's going to give me 2n. And then 2 times 3 will give me 6. And then plus this 3, that'll give me 9. So I'm going to have 2n plus 9. For the other one, I got 2 times n, so that's 2n. And then 2 times 3, that gives me 6 again, plus the 1, so I get 7. So make sure if you do that substitution at the end, you got to put it back in, and then simplify whatever you have, and then you get your final answer. So last one here. This one I can see there's only two terms, difference in the middle, so I'm thinking this one is a difference of squares, and all the numbers seems to be like they're perfect squares. So I'm going to write out the square roots of all these. Square root of 4 is just 2. Square root of x minus 2 squared is x minus 2. Square root of 25 is 5. And then square root of that y minus 4 squared is just going to be y minus 4. So to factor the difference of squares type, you made two sets of brackets. I'm making them really big because there's going to be a lot of stuff fitting inside of there. The first term was the 2x minus 2. So that'll go first. And then we got to do the plus and the minus. And then the second term was the 5 and the y minus 4. Now that I have that, what I want to do is I want to make sure that I have this as simple as I can get it. So I got to try to simplify this. So I'm going to distribute all of these into the brackets on each one of these and then simplify. So the first one, I'm going to have 2x minus 4 plus 5y minus 20. Then we got 2x minus 4 again, minus 5y plus 20. Just make sure you're careful of those negatives, right? So negative negative gives me a positive. And then inside the brackets now I can put the numbers together. Negative 4 and negative 20 can go together, and negative 4 and positive 20 can go together. So in the first one I got 2x plus 5y, and then putting my two numbers I got minus 24. And in the second one I had 2x minus 5y, and then putting the two numbers together I get plus 16. So lastly, I'm just going to write our homework questions here now at the bottom.